Okay, students, so we're moving towards the end of this section. What we're going to look at is briefly the product rule, quotient rule, and you'll be using these derivative rules throughout the semester. So, what I want to look at first of all is, you learned that the derivative of the sum is the sum of the derivatives. And let me just kind of demonstrate this like this. First of all, there's two ways to do this problem. One way to do this problem is to do the derivative of 3x plus the derivative of 4x plus the derivative of 5x. This is not the way you would do this probably, but that would just be 3 plus 4 plus 5, which would be equal to 12. Okay? Or a little bit sharper way to do this problem would be, hey, these are all like terms. So we have 12x, and the derivative of 12x is 12. So the reason I'm going over that is we want to see if that same idea applies to a product when we're working with derivatives. So let's take a look at this one. Okay, let's do two things. First of all, let's just try to do the derivative of each part. Okay, let's do like the derivative of x squared. I'm just writing the notational system down. You don't have to, though. So let's go ahead and see what happens if we try to do the problem this way. All right, well, we know the derivative of x squared is 2x. We know the derivative of x to the fourth is 4x to the third. So multiplying that together, you would get 8x to the fourth then. 2x times 4x to the third. Okay, well, let's try it this way. Okay, because this would be correct algebraically. Well, we know if we just put that together, we add the exponents. So you would really just be looking at x to the sixth. Okay, well, let's see. Do we get the same answer? F prime of x equals 6x to the fifth. Uh-oh, something's wrong. Okay, we got that way, got that way. Which way do you think's right? Yeah, this way's right. This way is totally wrong. You can't do it that way. Products don't work the same way that sums do when you're talking about derivatives, okay? So what we get is we develop what we call the product rule. I've written a little proof on here that you can look through. So the product rule goes like this. Anytime you have two functions multiplied and you're doing the derivative, you just write down the first function, then you do the derivative of the second, plus, then you write down the second times derivative of first. I always recommend that you try to learn rules as much as you can in words and in symbols. So I just look at it this way. The first times the derivative of the second plus the second times the derivative of the first, or do it more in a shorthand notation like this. First derivative of second plus second derivative of first. Okay, like that. Just in shorthand, you could almost go like first, second derivative plus second a derivative of first, like that. All right, you'll do this throughout the semester. All right, so I'm going to move down the bottom of the page, and what we're going to do is we're going to redo this problem. And remember, you know, the correct way to do this would be to just simplify, get x to the sixth, and then the derivative would be 6x to the fifth. Okay, that's the correct derivative on that problem. Excuse me. So let's go to the product rule. So let me show you how the product rule goes. All right, so if we do the derivative of x to the second times x to the fourth, well, you got two things. That's your first function, and this is your second function. So according to the product rule, what you do is you write down the first. You don't do anything with it. Then you multiply by the derivative of the second. Now, I'm going to set this up in notation, which I recommend. And then we write down the second, and then we multiply by the derivative of the first. Okay, so that's how that gets put together. Again, you got the first times derivative of second plus the second times derivative of first. Okay, just highlighting that. Okay, all right. So let's see what we get. Okay, this would be x to the second. This would be 4x to the third. This would be x to the fourth. That would be 2x. Okay, so let's see what we get. These go together. Okay, add the exponents. That would be 4x to the fifth added to 2 x to the fifth. Those are like terms. Look at that. We get 6x to the fifth. Hallelujah. Okay, so see, it works. That doesn't prove anything, but it certainly shows that it works in that case. Now Leibniz, here's a picture of Leibniz. Back in the day, these guys looked like rock stars. I think they were rock stars, personally. That long flowing hair looks like he played in an 80s, hair band or something. But this is Gottfried Leibniz, one of the co-developers of early calculus, along with Isaac Newton, who developed this ingenious notational system for the derivative. Okay? And he's credited for the product rule. All right. So let's go to the next page. Now I want to just sort of talk you through this proof. You're not required to know the proof in this class necessarily. But I think what I like to mention to students is all these proofs, notice that you're going to the, the definition of a derivative. So if you set this up, this is being set up in the definition of the derivative. This is limit of f of x plus h minus f of x all over h. Well, your function is this. Remember, when we've been setting up derivatives, whatever you're doing a derivative of goes there. And then you just change this by changing the x to x plus h. So that's how that would be set up in the difference quotient. And then really all this stuff is algebra. So there's kind of a little trick on this. And this is just kind of what mathematicians play with and come up with. They've added this quantity in here. Now see, that cancels out. Okay, and this is kind of something we do a lot of times in mathematics. See, we still have the first term, and we still have the last term there. And then what we're going to do probably is we're going to try to group this together somehow then. All right. So what's going on here is this is being broken up into two different limits. So we're breaking it up into this and into this. So let me kind of show you what's really going on. That gets grouped together. That gets grouped together. And that's really what we're doing here in this next step. And remember, we have a law for limits says the limit of a sum is the sum of the limits. So we're breaking that up into two limits then. Okay. Well, on this one, in this step, you just factor that out. So that can be factored out like it is there. And over here, it looks like the g of x can be factored out. So the next step could be written like this then. And actually, this step wasn't shown on here. But what you end up getting on here is, see, this part right here, just that little piece right there, is the derivative of g. That's what that is. And then if x goes to 0 here, well, that part right there just becomes f of x. Similar logic here. This part right here is the derivative of f prime of x, and then that g of x just goes there. So that's a good thing to look over and see if you can reproduce that, particularly if you're a math major. I don't know if I got any math majors. I don't have too many. Every now and then I have some. And of course, that's the kind of thing that you study a lot with a lot of depth when you get later in your major, is how to derive and prove things. All right, so that's really good exercise to look at. So what I'm going to look at next down here is finding derivatives. Just going to do a couple of derivatives in two different ways. And the first thing we're going to do on this is just multiply out. So let's just go ahead and take this function, multiply it out. So we would end up having f of x equals, the first term is 3x to the third. And then 3x times 3x is 9x to the second. 3x times 1 is plus 3x. You can kind of now go to this negative 4. You have negative 4x to the second. Negative 4 times 3 is negative 12x. And negative 4 times 1 is negative 4. So that's how that gets put together. So now what we get is 3x to the third. We got like terms, so let's put these go together. And notice these go together. So what I'm going to get is 9 minus 4 is 5x the second. 3 minus 12 is minus 9x. And minus 4. So just multiply it out. This is one way to do the problem. Now let's go ahead and do the derivative. And remember, we kind of learned how to just do this in your head, but if you're doing a derivative of sums and differences, you just do the derivative of each part. So this is 9x to the second This is 10x to the first. This is a linear term, so minus 9. And then the derivative of a constant 0. So that would be what you get for your answer is you get this. Okay. Now let's see how the product rule works on this then. So the product rule would go like this. Really the first function is just the whole thing 3x minus 4. The second function is just the whole thing x squared plus 3x plus 1. So when we go to the product rule, it goes like this, okay? Again, just first times derivative of second plus second times derivative of first, okay? So I write down the first, and I'm going to set this up in notation. I kind of prefer that you, when you're learning this, that set it up in correct notation before you do the derivative. So we do the derivative of the second, okay, plus the second, and then multiplied by the derivative of the first. Okay, so that's how the, whoops, that would be 3x minus 4. Okay, so that's your setup. First times derivative of second plus second times derivative of first. So once you learn how to get that set up, it's pretty easy to do. Okay, so just bring down the 3x minus 4. Do the derivative here. So you see you're going to do this derivative and you're going to do that derivative. That's the calculus. So we got 2x plus 3 is the derivative there. All right, so we got that taken care of. And then bring down the second function, x squared plus 3x plus 1. And then do the derivative of the second. And that's just like a line. Y equals 3x minus 4 has a slope of 3. The derivative is 3. So that's how that goes. Now we're just going to multiply this out and see if we don't get the same answer. So you would FOIL this. So this would be 6x to the second plus 9x minus 8x minus 12 plus, and then 3x to the second plus 9x, and then plus 3. Okay, so just kind of verifying in your mind what I'm doing there with the distributive property. It does look like we have lots of like terms. So we have x squareds that go together. We have x's that go together. And we have constants that go together. So let's see if we don't get the same answer. Okay, let's see. These go together. That's 9x squared. Looks like that would be 9 minus 8 is 1. 1 plus 9 is 10, so that's 10x. And then finally, negative 12 plus 3 is minus 9. So how about that? We got the same answer. Now, I want to ask you a question. Which way is easier? Which way is less work? That's what I should say. Yeah, I would agree. I think that that's less work. Okay, and that's in practice typically the way I would do this problem. Just multiply it out, then do the derivative. It's just a little less work to me. Now, there are times when you have no choice but to do the product rule, and we'll see that. Okay, so let's do this next one here. So we have y. Now, I'm going to show you how to do the shortcut on this. Remember, you can always write this out twice in FOIL. I like to try to get Calc 1 students to be really solid on that shortcut, because sometimes students aren't real solid on that coming into this class. So what you do is you really just square the first term. And in your head, 4x times 4x is 16x the second. So you can do that in your head. Then you square the last term. And you go ahead and take that negative 5 and square it. So negative 5 times negative 5 is plus 25. Okay? Then what you do is you multiply these two terms together. So you do 4x times negative 5, and then you double it. Okay, and just bring that negative sign down there like that. And then when you put that together, see, that would be 8 times 5 would be 40. So that would be minus 40x, like that. I kind of do this in my head. I look at that term. That term is negative 20x. If I double negative 20x, I get negative 40x. You want to try to learn how to do that in any situation when you're squaring a binomial. It's just quick thing you can do in your head. You want to learn how to do that. Okay, so on this one, let's just do the derivative. I'll just write y prime. You could write dy over dx also. So that would be, hold on. I want to do the product rule, so that's not what I want to do. I want to do the derivative over here. Let's do the derivative over here. Okay, so that would be 32x. This is a linear term, so it's the number in front, minus 40. That's a constant, so that derivative is 0. So that's what you would get as your derivative if you just multiply it out. And that's the way I'd do this problem. I wouldn't bother with the product rule. But I'm just at this stage just trying to show you how it works. So what we're going to do on this then is we're just going to write this as 4x minus 5 times 4x minus 5. Okay? And then this will be the first function. And this will be the second, like this. Okay, and then here's the product rule up here to refer to, and we're going to put this in the product rule. So this time I'll just say dy over dx, the derivative. What I do is I write down the first. I just write it down, so that is 4x minus 5. Then I multiply by the derivative of the second. You can certainly do that in your head. As I'm teaching this, I want to get you to get that notation down. All right, then it's plus, then we do it backwards. We do the second, which is the same thing. Can't go wrong on this, can you? And then you do times the derivative of the first. So I'll write that as d dx 4x minus 5 like this. Okay, now what we're going to do then is we got to do this derivative and that derivative and then simplify it out. Hopefully we'll get the same answer. I'm sure we will. Okay, so we get 4x minus 5 there. That comes down. This derivative is 4. Plus sign comes down. That comes down. And then that derivative again is 4. So now just multiply it out and see if you don't get the same thing. Let's do distributive property. So 4 times 4x is 16x. 4 times negative 5 is negative 20. 4 times 4 is 16x. And then minus 20. All right, you got like terms, put it together. 16 plus 16 is 32x. Negative 20 subtract 20 is negative 40. So indeed, we get the same answer. Okay, so really in practice, I think both of these problems, the logical way to do this is just multiply out and do the derivative. Now this section, we're just introducing the idea of a product rule. And then there's going to be, most of the time, you're going to have no choice but to use the product rule. But in these simpler cases, just multiply it out. Okay, so what I'm going to have you do is go ahead and pause the video and just do this the two ways. Multiply it out and find the derivative, and then do the product rule. Come back when you're ready, check and see if you're getting the right answer. If you get the right answer with both methods, there's a pretty good chance you're doing it right. Okay, good luck. Okay, so check out and see if you got it right. You should get the same answer regardless of which way you do it. Multiplying out's a little less work, so when you multiply it out, you get this derivative 4x to the third plus 2x. Okay. Then over here, the setup is like this. First times derivative of second plus second times derivative of first. So you'd end up getting this. And then when you multiply that out and collect like terms, you get the same thing. Now, sometimes textbooks show it this way. I like to show first times derivative of second. You can kind of write it this way if you want to. Plus second times derivative of first. That's just the way I guess I was taught how to do that, and I've been doing it that way for years. A lot of times textbooks will say derivative of first times the second, and then they'll say plus the derivative of second times the first. I guess I wasn't taught that way. Probably my calculus textbook showed what I did. It's just been so long ago I don't remember, but you can do it either way. I mean, it's the same thing. You know, you're going to get the same answer. So I don't care which way you do that. So that'll wrap us up there. Let's move on to the next page here, and then I'll what I'm going to do is just record this real short video, and then I'm going to do the quotient rule in a different one. So I like to do short snippets of videos, okay?